Hi everyone and welcome. This is going to be a trigonometry review. We're going to talk about the things you see listed in front of you. If at any point you feel like I'm going too fast, please just pause the video, rewind, review. Also, if you're in the virtual classroom, you can ask me any questions if something doesn't make sense or if you see a mistake, anything like that. Finally, also whenever I do a problem in the video, I would suggest to, pause it and try it yourself each time before I go through it. All right, with that in mind, here we go. So, firstly, when we're talking about right triangles and trigonometry, we want to be able to name the parts of a right triangle. So the first thing I want to say is, let's say I name the vertices of my triangle. One thing is the sides, if they aren't given names, they're just going to be the lowercase of the vertices. All right, so that's something that I think you should know. It'll come into play later, not even necessarily this chapter, but we'll keep it in mind. The more important naming convention, though, is the one we talked about before the break, and that's if I have a right triangle and I'm looking at a specific angle, like if I'm looking at this angle here, theta, right? Then the three sides now have kind of specific names based on where theta is. So the hypotenuse is easy. That's always going to be the longest side or the side across from the right angle. That one actually doesn't change. The other two, however, depend on where theta is. So my theta is up here. So the side next to theta, that's not the hypotenuse, that's going to be called adjacent. That's the adjacent side because it's the side next to theta. And then the side across from theta, right, on the opposite side of the triangle, is actually going to be called opposite. So when you have a right triangle and you're looking at a specific angle, then you have an adjacent, an opposite, and a hypotenuse. So just to run through that very quickly again, here's another right triangle. And now I'm going to put my theta down here in the bottom, and you'll see the hypotenuse is still in the same place, but the adjacent is now down here because it is next to theta, and the opposite has moved over here because it is across the triangle from theta. All right, and that is the naming conventions. Next, we want to talk just very quickly about having your calculator in degrees for this, right? So I'm probably going to use the Desmos scientific calculator, which you can put, it's online, or I think it is available as an app, and if it isn't yet, I'll have the IT person, Schaefer, release it as soon as possible. Other than that, feel free to use the Google calculator, it's fine. And you just want to make sure you're in degrees. You can see that switch I just made right there. It was in radians, it's in radians again, and now it's in degrees. And if you are going to use Desmos, you'll see the button right here, right? Degrees is showing, so it's in degrees, now radians, now degrees. All right, so we'll practice on the calculator in a little bit here. All right. Theta is the next thing. I already used it, but just a reminder, this circle symbol, like that, right? That's called theta. And this is just a variable, right? It's usually used to talk about angles, right? And so it's the one we're going to use a lot. But you could put an x or a y or any variable there. It doesn't make a big difference. Theta is just the norm. All right. Next, on to sine, cosine, and tangent. All right, so the idea is that sine, cosine, and tangent, as it says up here, they are just a ratio of two sides of a right triangle, each of them with their own ratio. All right, so we'll write that out real fast. So sine of theta, right? We wouldn't really write it like that, so I'll just put this first. Sine, we're going to write as S-I-N, right? Cosine, we're going to write as C-O-S. And tangent we will write as tan. Right? So the idea is if you're looking at a specific angle, right? So sine of theta, where theta is an angle in my triangle, sine of theta is going to be equal to opposite over hypotenuse, right? Cosine of theta is going to be equal to the length of the adjacent side over the hypotenuse, and tangent of theta is going to be equal to the opposite side over the adjacent side, right? And I'll draw that out here in a moment with some examples. I just want to say one way that I was taught to remember this that still sticks with me is SOHCAHTOA, right? So you just remember that phrase, SOHCAHTOA, and how it's spelled. And you can see here, you have sine, right? Sine is equal to opposite over hypotenuse. So the O is here and the H is there. You have cosine is equal to adjacent over hypotenuse. So the A, I'm sorry, that's supposed to be an A. Adjacent over hypotenuse, you see the A is there and the H is there. And then the last one is tan, right? And that is opposite over adjacent. So the O is there and the A is right there. So that's just one way that I've used to remember it.